Thought-controlled prosthetic limbs, wheelchairs and computers may be available within a decade, say Australian scientists who are planning to conduct human trials next year on a high-tech implant that can pick up and transmit signals from the brain. Animals have already been tested with the device, called a stentrode, which is the size of a matchstick and planted inside a blood vessel near the brain. It uses a web of small electrodes to pick up neuron signals from the brain and converts them into electrical commands that may one day, the scientists hope, allow paralyzed patients to control a bionic limb or wheelchair. The big breakthrough is that we now have a minimally invasive brain-computer interface device which is potentially practical for long-term use, said Daryl Bryan, head of medicine at the Department of Medicine and Neurology at the University of Melbourne. The current method for accessing brain signals requires complex open brain surgery and becomes less effective over several months, which means it is rarely applied, he said. The stentrode is less invasive because it can be inserted through the vein in a patient's neck and placed in a blood vessel near the brain. The animal trial was on the functionality of the stentrode to pick up neural signals, not the converting of the electronic signals into movement of bionic limbs, which is established technology. Dr. Ganesh Naik, from the University of Technology Sydney, who is not involved in the project, said animal trials did not always translate into successful human trials. If it functions as it should at the human trial, it will be a massive breakthrough, said Ganesh. Other potential uses for the stentrode include monitoring the brain signals of people with epilepsy to detect an oncoming seizure. If successful, the device could also allow a patient to communicate through a computer, said Professor Clive May from the Florey Institute of Neuroscience and Mental Health, who is working on the project. People would need to be trained in how to think the right thoughts to make it work, like learning to play music. You need to learn it, but once you do, it becomes natural, May said. The device was developed by Melbourne University, the Royal Melbourne Hospital and the Florey Institute of Neuroscience and Mental Health. The project is funded by both the Australian government and the US military, which sees potential benefits for paraplegic veterans. Copyright Thomson Reuters 2016.